Good evening, class. It's nice to see all of us here ready for the class today. Today, we'll be taking a different topic, but it's a build-up from the topic we did last week. Here, let me introduce the topic for us today. Our topic for discussion is limiting factors, limiting factor decisions. Okay, let me take you through the class rules that we should all abide by. The class rules are important, that's why we take them every time we have classes. The first one is that students should be muted, both on audio and video. This class is being recorded, and so we want everybody to maintain proper decorum while in class. Feel free to use the chat button to ask your questions. Like as I always say, take a jotter, write down the questions that you want to ask, first of all, and maybe by the time the lecture progresses, you will realize that the question you are about to ask has been answered by the lecturer. And so there may be no need to write the question using the chat. Or in the case that the question did not get answered, put it down there in the chat. I will try my best to leave about 15 minutes to the end of the class so that we can look at these questions and tackle them. Also, you are advised to listen attentively during lectures instead of writing. But like as I said, you can jot down any question that will come to your mind. This is because the mind thinks faster than how we speak. And so you may find out that you may have questions that you may want to find answers to as the class progresses. Okay, if you have connection problem, call the number stated in your material. So let's go straight to the topic for today, limiting factor decisions. If you look at the topic here, limiting factor, we didn't say factors, we say factor. That means it is just a factor that limits. What are they limiting? Well, look at the introduction here. It says this topic explains the concept of limiting factors, how to identify them, and how to formulate an optimum production plan when there is a single limiting factor. So you see here, like the topic said, limiting factor and not factors. Yes, there may be factors that can limit what we are doing in production, but we'll be talking about a single limiting factor. Now, problems that involves more than one limiting factor will be solved using linear programming, and that is beyond the scope of this paper. But it is worth mentioning that when you graduate to the PM class, you'll be learning linear programming. So at the end of the class, you will explain the issues of limiting factors. You can identify limiting factors that limit production. You're also going to carry out a limiting factor analysis to formulate an optimal plan that maximizes your contribution and your profits. Now, one of the functions that management perform is decision making. Now, they decide how the business should run, what should be produced, how to produce, who to produce, and who to produce for. All these are decisions that management take. So decisions involving a choice about what should be done between different possible options abound. And so for a manager to make good quality decisions, they need to get relevant and reliable information that they can base these decisions on. Now, in a business, it is often assumed that in budgeting, a company can produce as many units as it can sell. And so the only thing that could limit your production is how many you can sell. So that's normally the major principal budget factor or the limiting factor. What will limit what we can produce is how many you can sell. How many you can sell will be determined by how many customers that you have. So now, when we talk about limiting factor, we go beyond sales. Now, our sales will not be the limiting factor here in your exams. That means if sales is not our limiting factor, what could be our limiting factor? Now, in economics, we were told that factors of production are often called the land, capital, labor, entrepreneur. Materials could be there. So some of these factors of productions could limit our production. Let's say, for example, we are looking at capital. So without enough capital, you cannot venture in that production line. And so that has limited what you can do by way of production. Let's look at materials. If you can't get the materials in the number of quantity that will satisfy your customers, that means you are limited by way of materials. Let's look at labor. If after getting all your supplies and you cannot find appropriate labor that will meet the supplies, then you are limited. So when you are in short of this key production resource, then you say that you have limiting factors of production. Now, like as I said, if the company is producing just one product and there is a limiting factor, which we have said that in this exam is going to be just one limiting factor, then there is no problem. Let's say, for example, your customers have ordered for 500 loaves of bread and your labor supply can only give you 300. Then go ahead and do the 300. That is as much as you can do. That is just one product. Now, what if you are making two products, say bread and cake, and both of them are using flour? Your customers have ordered for 1,000 loaf of bread and 1,000 pieces of cake. And you have bag of flour that is short, you cannot use it to produce the 1,000 loaf of bread and the 1,000 pieces of cake. So how can you use this limited factor of production to satisfy your customer and in such a way that you will make your maximum profit? That is what this lecture is going to answer. When a company makes and sells more than one different product with the same scarce resources, a budgeting problem is to decide how many of each different product to make in order to sell and maximize profit. Now, we're going to look at identifying limiting factors. How do you identify a limiting factor? If you remember the question that we did in is it throughput accounting, you find out that you were given some items and you were not told which one of them is the bottleneck or the limiting factor. So you have to calculate to find out which is the bottleneck or the limiting factor. Sometimes a question will just go ahead and tell you labor is the limiting factor, or material A or material B or so is the limiting factor. If that is given to you, that makes life easy for you. Means you have identified the limiting factor. But when you are not given this limiting factor, you are not told specifically which one is, then you must identify the limiting factor by calculating the budgeted availability of each resource and the amount that is needed to meet the available sales demand. This is what I mean. What I mean is this: if you are not told if materials and labor that are factors of production here, which of them is a limiting factor, all you need to do is this: find out how much quantity you are required to make. Find out how many pieces of material or how many kilograms of material or units of material will be required to make that sales demand. When you do that, you now look at how many do I have. Now, if what is required is more than what you have, then that means there is a shortage on your part, and that's the limiting factor. But if what you require is lower than what you have or equal to what you have, then that is not a limiting factor. It means what you have can meet what is required. And go ahead, nothing is restricting you. But if what you have is less than what is required and something is restricting you, that means you've identified the limiting factor. Let's look at a question now to see how we can identify a limiting factor. Now, this question here is: a company manufactures and sells two products. Now, typically in your exams, you are going to be seeing a limiting factor where there are 2 or 3 products. It will be minimum of 2 and maximum of 3. So you see that you have the product X and your product Y. Sorry. So you have 2 products here, product X and product Y. Both of them are the products that the company is currently making. And now they are using 2 different machines. So you see what I'm highlighting? They are using 2 different machines. Now the time taken to make each product together with the maximum time availability and contribution per unit and demand are as follows. So you can see product X and Y, look at the available hours, look at machine type 1. For product X, the available hours for machine type 1 here says that you can make product X 10 minutes. You've made product X. So what does 10 minutes translate into hours? So if 60 minutes make 1 hour, then how many hours will 10 minutes be? So it is going to be 1/6 of an hour. It means that if you make 1 unit in 10 minutes, in 60 minutes, you are going to make 6 units in 1 hour. So that is what this 6 per hour here means. It means that you're going to make 6 units in 1 hour, or it means that 10 minutes is equal to 1/6. So if you are making 6 minutes in 1 hour, per unit, sorry, 6 minutes per unit of product Y, that means in 1 hour, you're going to make how many minutes? Make 1 hour is 60. So you simply say 60 divided by 6, it means you're making 10 units per minute. So this is like 1/10. 6 minutes is like 1/10 of an hour, or you're making 10 units of goods per hour. The hours available for machine X is 3,000 hours. This is the number of hours available for machine X. Now let's go to machine Y. 5 minutes for machine 2, sorry. 5 minutes for product X. It means you're doing 12 per hour, or this can be said to be 1/12. Same thing here, 12 minutes, said to be 1/5. 4,200 hours. This is the available hours. Now look at your sales demand. Your sales demand, as I said, is not your limiting factor. So you can handle all of these if there is no restriction. So requirement, which of this machine is a limiting factor? So let's find out which one of them is the limiting factor here. Okay, let's go to our answer sheet here. Let's look at the solution. Now, look at for solution to exercise LF01, machine type 1. Now let's look at our products, X and Y. Now look at the sales demand that was given in the question. The sales demand we said was 12,000 units. See it here, 12,000 units and 15,000 units. So your 12,000 units and your 15,000 units are there in place. Look at your hourly requirement, 6 units in 1 hour, 10 units in 1 hour. So what is the number of hours required? It means that if you are doing 12 units as a whole, totally, and it takes you 6 units in 1 hour, that means you want to know the number of hours that is required. You simply say 12,000 units altogether divided by 6 units in 1 hour, that gives you 2,000 hours. So 2,000 hours is the number of hours that is required to do product X. You are going to do the whole of 12,000 units. So this 12,000 units here requires 2,000 hours. Now look at this 15,000 units. How many hours does it require? Simply say 15,000 units is what we are going to do total, and we are doing 10 units in 1 hour. So 15,000 divided by 10 gives us 1,500 units. So 1,500 hours. So when we add these 2,000 hours with this 1,500 hours, what we are getting here is 3,500 hours. But look at the question. The question says here that available hours is 3,000 hours. So your available hours here is 3,000 hours. So if that's the case, this is what is required of you. This is what you currently have available. Do you have a shortage or do you have a surplus? You have a shortage of 500 hours. So you can be guessing it now correctly that your limiting factor is machine type 1. So your limiting factor here seems to be machine type 1. Now, once you've done and gotten your limiting factor as 1, don't do the other one, because in the exam, 2 limiting factors will not be given to you if you are trying to find the limiting factor. If the question is all about limiting factor, to save time, once you've identified limiting factor, if that's the first one, then you struck gold. Just work with it, because the second one will never be a limiting factor. So look at it now. Sales demand, like before, is 12,000 units, 15,000 units for Y. Look at the number of requirements, hourly requirement as before. So is 12 units in 1 hour, is 5 units in 1 hour. Number of hours required, do your maths. 12,000 divided by 12 because it's 1,000 hours. Here, 15,000 units divided by 5 units gives you 3,000 hours. When you add them together, it gives you 4,000 hours. And what does the question says is your available hours. Available hours here was 4,200. And so if your available hours is 4,200, it means you have a surplus of 200 hours. You have 4,200 hours to play with. And what is required of you is 4,000 hours. That means you have extra 200 hours of surplus hours. So that shows that machine type 2 is not the limiting factor. So we've seen how we can identify limiting factors. So we have identified a limiting factor here as machine number 1. So what are the steps that we can take to carry out a limiting factor problem? How can we solve a limiting factor problem? Now, when there is just one limiting factor other than sales demand, now the total profit will be maximized in a period if we maximize the total contribution earned with the available scarce resources. How do we do that? We say before, contribution is much more important than profit. This is because you can make a profit, you cannot make a profit if you don't make contribution. You cannot make a profit if you don't have a contribution. Okay? So any contribution you earn, increase in contribution is affecting the profit. We said before, when your contribution has exceeded or adequately covered your fixed costs, any extra contribution you make is increasing your profits. We say also that Contribution is what helps a manager or management to make decision. And when we are looking at single limiting factor, we are trying to make decision here. So when we are making more than one product, we want to decide which of these products should we make. How many should we make of each product so that we will use up our scarce resources in the most efficient way and make the best or biggest contribution we can ever make. There are about 6 steps you can take to achieve that. Step number 1, calculate the contribution per unit of each type of goods that you are producing. Let's say we are doing cake and bread. How much do you sell a piece of cake? That's the selling price. What is the variable cost for making that bread or cake? That's your variable cost. So when you say your selling price per unit minus your variable cost per unit, that gives you your contribution per unit. That is important because we said contribution is very important. But now when it comes to limiting factor, something is much more important than contribution per unit. Let's go to step 2. Step 2 says identify the scarce resource. Now that scarce resource we've identified in the first question. If you are not told, you simply look at your budget availability plus your budget requirement. Whenever there is a shortage, that indicates your scarce resource. But sometimes in the question, you may be given that scarce resource. So if you are given, thank the Lord. Now, you have to calculate the amount of scarce resource that each type of goods will need. That is what I mean by scarce resource per unit. So if it is material, you say material per unit. If it is labor, you say labor per unit. Why must it be per unit? Because in our steps, we said we are calculating contribution per unit. So everything here now will be in per unit. So our scarce resource will also be in per unit. So when we identify our contribution per unit, we identify the scarce resource per unit. The next step is step number 4. We'll divide this contribution per unit we've gotten with the amount of scarce resources, which is the scarce resource per unit, to get what we call contribution per unit of scarce resources. This step number 4 is very, very important. In fact, contribution per unit of scarce resource is far more important than contribution per unit, because something can be contributing a higher contribution, but when it comes to the scarce resource, it could be giving the lowest contribution per scarce resource. So don't get it twisted. Contribution per unit is important, but when you are trying to look at limiting factor, contribution per scarce resource is more important. The next thing to do is to rank the goods or the service in order of the contribution per unit of scarce resource. So you are ranking based on what you got in step number 4. So your ranking comes from the results you get in step number 4. In step number 6, you construct a production plan. What is a production plan? A production plan is how do you produce these items using up all these scarce resources. Don't forget, your production plan will be based on the ranking. So you see, step number 5 takes up from step number 4. Step number 6 picks up from step number 5. So when you are saying steps, you must follow that logical step. If you miss any of this step, then your answer will not be correct. Now, your production plan is going to look like this. On the first column, you are going to have your ranking, where you have them first, second, third, fourth, and so on. Then the products, according to the ranking. Which product is ranked as first? Put that there. Which one is ranked second? Like that. What you are doing is what we call scale of preference in economics. It means that you have itemized your item according to scale of preference of the scarce resource. It means that what you rank as number 1 will be produced first. Every other thing will serve as opportunity cost to it. It means that you don't produce anything until you are done with you. What you not do when you do your ranking is to set these units of goods in that way. Sorry, my internet. Okay, we said that your production plan will have your ranking, your product, then that scarce resource that you are basing your ranking on should also come. So you have your scarce resource, this labor, this material comes next. Then the number of quantities that you are supposed to produce. Now that is the critical point there. That is what you want to achieve. Now, how many of these quantities would you produce given the scarce resource? We're going to see a question where we apply all of this. Now, example LFO2, limiting factor analysis, gives us exactly what we are asked to do here. Look at this question. That's the same kind of question we saw in LFO1. We'll be using this question for this example again. A company manufactures and sells 2 products, product X and product Y, which are both manufactured using 2 different machines. The time taken to make each product together with the maximum machine time availability and contribution per unit and demand are as follows. We see that machine type 1, we have for X and Y 10 minutes, 6 minutes. Available hours is 3,000 hours. Machine type 2, X and Y 5 minutes, 12 minutes. Available hours 4,200. Sales demand X and Y 12,000 and 15,000 units. Now the difference between example 1 and example 2 is the addition of this contribution per unit. 7 naira, 5 naira. Now it is important that this question has contribution per unit because we were not given the selling price nor the variable cost per unit. But if we are given these, then you will not be given contribution per unit. So anything that will help you to get contribution per unit will be given to you. Now, remember we said machine 1 in our first question is the limiting factor. They are telling us here that given that machine 1 is a limiting factor, what is the optimal plan? If you remember, that is our step 6. You cannot get to step 6 by jumping steps. You must go gradually. Step 1, step 6. So they say the production plan which maximizes annual contribution and hence profit that the company should adopt. So you are going to find this production plan and you are going to suggest to management that, hey, management, you should adopt this plan. You will get your maximum contribution and maximum profit from this plan. Now let's see what we're going to do here. So let's look at our solution. Our solution to LF2. So what do we have here? The first step, we said, step number 1, we should identify or calculate the contribution per unit. That's step number 1. You see that contribution per unit was given to us, 7 naira, 5 naira, no problem. Step number 2, identify the limiting factor. The limiting factor was identified for us as machine number 1. No problem. Step number 3, find the limiting factor per unit. Limiting factor per unit here, we were given machine 1 for X was 10 minutes, machine Y 6 minutes. No problem. This 6 minutes or this 10 minutes here and 6 minutes here are important because don't get it twisted and go and write 6 per hour. No, we are asked here per unit, limiting factor per unit. And so we'll take what we have here. It is 10 minutes per unit. Although we know that that 10 minutes means 6 units per hour. So don't get confused. We are not looking at per hour here. We are looking at per unit. So anything that gives us per unit is what we are taking. So what do we do now that we found there's the next step, which is step number 5 or step number 4, sorry, is contribution per limiting factor. What this means is contribution per limiting factor is, what is our contribution for X is 7. What is our limiting factor for X is 10 minutes per unit. So 7 divided by 10, that means in our scarce resource here, this is giving us 0.7 naira in 1 minute. If you apply the same technique here, 5 divided by 6, you get 0.83. This is giving us a contribution of 0.83 naira per minute. So if you're going to rank, which one of them is giving you the highest ranking? So look at it here. This is the first when it comes to the ranking because this is 0.83 as against 0.7. So you see, this is important. This contribution per limiting factor is important than this because if you are to rank based on contribution per unit, you'll be tempted to rank X as the first. But you see, X is giving us a higher contribution per unit if there was no restriction. But now that we have restriction, X is not the one giving us the best contribution so far. What is giving us the best contribution is Y. So that's why you have to do this. Now we'll go to step 6. Step 6 says your production plan. What is your production plan? So we say you do your ranking, put your first and second here, your first and your second. Your first is product Y, the second is product X. Beautiful. Now look at the We'll jump this sales unit for now. Okay, let's not jump it. Sales units. In the question, we were told that our sales unit for Y is 15,000. So look at what we do. After identifying that our sales unit is 15,000, we'll write it tentatively. And we'll ask ourselves, since machine 1 is the limiting factor, how many of machine 1 hours is being used when we do 15,000 units? So look at it here. It means that we have 6 minutes. Let's look at it now. 6 minutes in 1 unit. Now, if we are making 6 minutes in 1 unit, then we have 15,000 units. How many hours do we need to make? It means that we have 15,000 units, all of material, all of product Y, divided by 6 minutes. Divided by 6 minutes, it gives me 2.5 divided by 60. Sorry, got it mixed up. Let's look at it this way. 6 minutes is for 1 unit. How many hours is 6 minutes? 6 minutes, 6 divided by 60 gives you 0.1. Now, it means that for 1 unit, you are using 0.1 hours. So if you have to do 15,000 units, you're going to multiply by 15,000, and that gives you 1,500 hours. So that's why you see the arrow goes from here to here. So you understand that you are moving from your left to right. Granted, you have 15,000 units. And 15,000 units, right? But we said that 1 unit takes 6 minutes. But we want to convert it to hours. We said 6 minutes converted to hours, you have to divide by 60, and it gives you 0.1 hours. So that means 1 unit, 0.1 hours. 15,000 units will be multiplied by 15,000, which gives you 1,500. Now that you've done that, your contribution per unit will be brought here. Now, take note, this is not contribution per scarce resource. This is contribution per unit. The original contribution per unit that was given to you, that is what will be used to know your total contribution. The contribution per scarce resource was used to do your ranking. That is what is only used for, to do your ranking, and so that you will not exceed the 3,000 hours available. But your contribution per unit is still there. So all you need to do is the 15,000 you've gotten so far, 15,000 times 5 naira per unit. Your contribution gives you 75,000 naira. That is the total contribution you are making from product Y. Now let's go to product X, which is the second rank. Then what is the number of sales units that we are supposed to do here? It's supposed to be 12,000 units. But why are we having 9,000 units here? Now let's look at it. If we are to use 12,000 units, look at what's going to happen. If 1 unit takes us 10 minutes, 10 minutes divided by 60, it means this is the number of hours that is going to require. 1 unit, 0.167 hours. multiplied by the 12,000 hours, you see, you're going to get 2,000. If you add 2,000 to the 1,500 hours that we already have in the first one, you're getting 3,005. That was why the question here was saying that, that was why the question here, when they give you 3,000 hours, it shows that it's the limiting factor, because what is required to do everything was 3,005, as we did in the first time, and we got a shortage of 500. So you see that you cannot do the whole 12,000. And so what do? You see the arrow is pointing backward. What you do is this. Your total hours is supposed to be, sorry, let me use this. Okay, let me still use this. Your total hours is supposed to be 3,000 hours, right? If this is your total hours, 3,000 hours. Now, the first one gives you 1,005. So for you to know the second one, all you need to do is your total minus this first one of 1,005. That means 3,000 minus 15 gives you 1,500. Now that you've known this, you are going to go backward. How many units should be here? Okay, so look at what you're going to do. All you need to do is this. This product X, okay? You have 10 minutes, 10 minutes, which is how many hours? Divided by 60. So this is what you have. All you now do is 1,500 hours divided by, let me do that again, divided by 10 over 60 will give you 9,000 hours, 9,000 units rather. So all you are doing is you are moving backward. When we went forward, we were saying 15,000 units multiplied by the time for 1 unit. So that was what we got, this 15,000. When we are working backward, we use the inverse, which is divide. So we've gotten this figure here, we divide to get this figure here. If we are moving forward, we multiply to get this figure in forward. From here, going backward, we divide to get the figure here. So the last figure, when you find out that you've exhausted your total resource, if any choice is giving you an option that exceeds your resource, you have to go and do backwards. So you don't go forward, you go backwards to determine how much units to be produced. So if you look at it again now, the construction plan, the plan is constructed as follows. Y is ranked first. So the company needs to make as many of these as possible. The most it can sell is 15,000 units, which would take 1,500 hours. If you're doing 10, 10, 10 per hour. So if you're doing 10 per hour, all you need to do also is to divide 10 from 15,000. You will still get your 1,500 hours. That's another way to do it. Then the company has 3,000 hours available. So it has 3,000 available and you're just needing 1,500 hours, you can do all of these. Now the company has 1,500 hours left. X is ranked second, and the most of X that can be sold is 12,000, and this will need 2,000 hours. We are doing 6 per hour. All you need to do is to use that 6 to divide from 12,000 to get your 2,000. This means that only 9,000 can be made because we cannot do the whole 12,000, because what is remaining is 1,500 and not 2,000. And that can be found as follows: 12,000 multiplied by 1,500 divided by 2,000 hours. So that will give you 9,000 units that you require. So what we mean is that look at what you are supposed to produce. This is what you are supposed to produce. But this is what is available divided by what is required. Gives you 9,000. So whichever way, do it, that's fine. So we've talked about how to identify our limiting factor. We are going to be given just only one limiting factor. We're not going to be given more than one. Then your products, you're going to be given more than one product. You're going to be given 2, 3, minimum of 2, maximum of maybe 4 or 5. Maybe given 4 or 5. And you'll be asked to look for the optimal plan, optimal contribution plan. Now let me make a little note here. How do you know that the question you are solving is a limiting factor question? 1, you will see the words limiting factor. Now when you hear the word limiting factor, don't just conclude that it is limiting factor alone. This is because sometimes throughput contribution, throughput accounting, they will still want to give you the same set of information. But when you hear the word bottleneck, then you say, wow, that's the language for throughput. When you hear limiting factor, then it knocks off throughput accounting, you are doing limiting factor. But that doesn't mean that when you hear just limiting factor, then it is limiting factor that you are doing. Because there could be more than one limiting factor. When there are more than one unit limiting factor, then this method cannot be used. That is when you now do your linear programming. But when you carefully look at it, that they are not using the words bottleneck, but they are using the words limiting factor. And it is just one limiting factor. Then you know you are in the right track using the procedures that we just mentioned. Remember the steps. Identify first of all, find the contribution per unit of each of the products. Then identify the limiting factor. Then look for limiting factor per unit. Look for contribution per limiting factor. Then you rank based on the contribution per limiting factor. And the last one, which is the 6th step, is produce according to ranking. Utilize all the available resources. Let's get to exercise LF03. Let's look at the next question. Now you see that this question has exceeded up to 4 units. This one says a company makes 4 products, A, B, C, and D using the same direct labor workforce on all the 4 products. It uses the same direct workforce. What does it mean? That's labor. Now, when they're telling you using the same direct workforce, it means they are hinting that this would be the limiting factor, because a limiting factor is something that all the products will be competing for, but it's not available to satisfy all of them. So you see, they use the same number of workforce. The company has no inventory of finished goods. Direct labor is paid at 12 naira per hour. Now, direct labor, 12 naira per hour. To meet the sales demand in full, you see, that means your sales demand has to be met, and it is not your limiting factor. To meet the sales demand in full, we will require how much? 12,000 hours of direct labor time. So if they tell you this, they are trying to give you a hint again that labor hours is your limiting factor. They have said it, the first hint here, same direct labor. When you see same, word same here, that all of them using the same of this shows that it is likely to be scarce. It is very important, likely to be scarce. Second hint here, they are giving you the number of hours that is required. Now, to clinch it that is the limiting factor, look at what they said. Only 6,000 direct labor hours are available. They now told you that, yes, this is what is required, but this is available. So you see, requirement is 12,000, availability is 6,000. There is a shortage of 6,000, and that makes it your limiting factor. Budgeted data for the company is as follows. Now look at the budgeted data. Now requirement, calculate the optimal production plan. Now that's step 6, optimal production plan. You see here, the question did not directly tell you that labor time or labor hours is the limiting factor. They didn't directly tell you. But what they did here was to give you 2 sets of hints to show you that labor is your limiting factor. The biggest hint you should be watching out for is 6,000 direct labor hours are available. If they give you that, it means they have told you this is likely going to be the limiting factor. But sometimes they might tell you, they might give you 2. For example, we have direct material costs, we have direct labor. They might tell you the number of direct material that is available. They can also tell you the labor hours that is available. They are asking you that among the 2 of them, you should determine which is the limiting factor. If they tell you that, then you do what we did in example 1. But now, no need to do what we did in example 1. So we just carry on. Sorry, I was tasty. So how do we solve this problem? Remember our steps. Our steps are important if we must conquer this question. So let's look at the steps and let's see how we can solve them. This question using these steps. Step number 1 is to look for contribution per unit. Now look at this question. In our production data here, there was nothing like contribution per unit here, but they gave us things to help us get contribution per unit. So we know that our contribution per unit is your selling price less your variable costs. So these are your variable costs. So let's see how we did it here. So our variable costs, direct labor and direct materials was 3 naira, 6 naira, 5 naira, and 6 naira. Direct labor costs 6 naira, 12 naira, 3 naira, 9 naira respectively. And the variable overheads are stated here. Now look at the total variable costs. The variable costs happen to be these figures here. So your variable cost is when you add all of these. 3 plus 6 will give you 9, 9 plus 2 will give you 11. The same thing, you add all of them, gives you your variable cost. Your selling price was given to you in the question, so you bring your selling price down. So what you will now do is to look for your contribution per unit. Your contribution per unit is going to give you your selling price, which is the second one, not the first one. So it's not everything you see up, you use to minus the down. 15.5, which is your selling price, minus 11 gives you 4.5. Second one there is 29 minus 22 gives you 7. 11.5, the third one, minus 9 gives you 2.5. And lastly, 27 minus 18 gives me 9. Now that we've found the first step is contribution per unit. Second step, look for the limiting factor. They have told us it's labor. So we have identified the limiting factor, that's labor. Okay, now we need to do the step 3. Step 3 is to identify your limiting factor per unit. Now, what we are given here is labor costs. So if you look at everything here, it's in naira. These labor costs here are in naira. So don't go and use this. What we need is labor hours. What we need is labor hours per unit. That is the scarce resource. They didn't tell us that the scarce resource is labor costs. What we look at here is labor hours are available, not labor costs. So there will be a need for you to convert your labor costs per unit to labor hours per unit. Now, look at what we got here. The question says direct labor is paid at 12 naira per hour. What this means here is 12 naira per hour. It means if you are to make product X, product A, and you are spending 6 naira in 1 unit, you are spending 6 naira in 1 unit, and you are being paid 12 naira, you divide it by 12 naira, it means that you spend 0.5 hours in 1 unit. So you see, if you are spending 0.5 hours in 1 unit, that means in 1 hour, which is 30 minutes here, is 0.5 hours. In 1 hour, you would have made 2. You would have made 2 units. And you see, they are paying you 12 naira for 1 hour. That means they have paid you 12 naira for the 2 units you made. If you divide it by 2, it means that 1 unit, you are making 6 naira, as stated here. So what we do now is, how do we convert our labor costs to labor hours? I showed you there in my solution how we did the conversion. First of all, we brought our labor cost here. So labor cost here from the question it says this is 6 naira, this is 12 naira, this is 3 naira, and this is 9 naira. And now look at the labor rate. We were told that we are being paid 12 naira per hour. So all of them contains 12 naira per hour. So what do? We simply say 6 divided by 12. We did it before, give you 0.5. When you divide 12 by 12, you get 1. When you divide 3 by 12, you get 0.25. When you divide 9 by 12, you get 0.75. Now, this is our scarce resource. Direct labor is our scarce resource. Now that we've found our contribution per unit and our limiting factor per unit, all we now need to do is to get our contribution per limiting factor. So see, look at how we do it. Our contribution per unit for A was 4.5, which is this 4.5 here, divided by contribution per limiting factor 0.5. What we get here is 9.0, which is this 9.0 here. For the second one, it is 7 for B divided by 1, and we got 7. For C, it is 2.5 divided by 0.25, and we got 10. And for D, it is 9 divided by 0.75. And what we get is 12. So now that we've got our contribution per limiting factor, what do we need to do? Because this is the most important of them all. And this is only gotten because we want to rank. That is the only usefulness of getting contribution per limiting factor, is for the purpose of ranking. What do? Which one carries the first position? Of course, it's D with a 12. It's 12. So surprisingly, when we compare contribution per limiting factor with contribution per unit, D was still carrying the first. Fine. The second is C. But you see, C here in contribution per unit happens to be the last. But in contribution per limiting factor, it is the second. Now, the third is A, which would have been third here. Fine. And the last, which is 7 here, which is the fourth, would have been the second. So you see, we don't go by contribution per unit, we go by contribution per limiting factor, just for the purpose of ranking. When we finish ranking, the work of contribution per limiting factor ends. So what becomes important is the contribution per unit, as we shall see as when we do our production schedule. So you see your production schedule, there's a contribution per unit, which is stated here, which are these contribution per unit we calculated before, and not this contribution per limiting factor. So we rank D as the first, followed by C, then by A, then by B. So look at what we do. Our sales unit from the question, D is 4,000. And so let's look at it. D is 4,000. And I want you to do something for me. Draw your production schedule. And under the labor hours, which is the scarce resource use, go and put this 6,000. Go and put this 6,000. Now, this 6,000 is very, very important for me because from the question, let's get the question again. The question says, only 6,000 labor hours are available. So you got to put that 6,000 here, 6,000 hours under here, so that you find out that you don't exhaust more than 6,000 hours. So you exhaust the whole of the 6,000 hours efficiently. So D, the highest number of sales that we can make in D is 4,000 units, right? So, but how many hours is it going to use? So how many labor hours is it going to use? So look at D, the labor hours is 0.75. So what we normally do, we'll say 0.75 hours for 1 unit multiplied by 4,000 units gives me 3,000 hours. So if it gives me 3,000 hours, that is the labor hours used. Then I will go back to here. How many of unit C is supposed to be produced? 8,000. So let's see. We bring our 8,000. Fine. How many labor hours is C? 0.25. So once again, 8,000 multiplied by 0.25. It gives me 2,000. If you add your 2,000 to 3,000 for the first one, which is D, you have a total of 5,000. That means the whole 6,000 hours has not been fully utilized. That means you can do every of D and every of C. Let's go to the next one, which is A. How many units of A are we supposed to do? 4,000. So what you do, tentatively with pencil, you write 4,000. Now, normally you'll be looking at how many is remainder. So we have 5,000 used up already. 1,000 will be the remainder. So, but let's see what will happen if we use 4,000 units of A multiplied by how many labor hours? Labor hours is 0.5 multiplied by 0.5. All we will get is 2,000 hours. But what was left is 1,000. So you cannot do every of A. You have to scale it down. So what do? You see the arrow of these other ones here, they were moving forward, moving forward. When we get to a point where we have exhausted everything and we have exceeded, we start moving backward. So we look at it now, 1,000 hours is still remaining. So we look at it now, 1,000 hours is still remaining. So all we need to do is 1,000 hours. The other time when we are moving forward, we are multiplying. This time around, we are going to be dividing it by 0.5. And that tells us that we need 2,000 units to be produced here. So 2,000 units should be produced and sold. Now, we still have to do B, right? So bring our B, the fourth, and we look at the number of hours. We've exhausted everything. And so, of course, here will be 0. And if here is 0, 0 divided by 1, which is the number of labor hours here, still going to give me 0. So we're not going to produce any of B. So now look at the contribution. Sales of 4,000 multiplied by 9 naira gives me 36,000. Sales of 8,000 units multiplied by 2.5 naira gives me 20,000 naira. Sales of 2,000 units multiplied by 4.5, let's do that. 2,000 units multiplied by 4.5 gives me 9,000 naira. And of course, 0 multiplied by 7 naira still give me 0. So when you add them up, you get 65,000 naira as your total contribution. So what you advise your company is produce your production plan as follows. Unit A, 2,000. Unit B, 0. Product A, 2,000 units. Product B, 0. Product C, 8,000 units. Product D, 4,000 units. That is if you want to go in order of A, B, C, D. But if you want to go in order of your production schedule, you say you produce accordingly like this. So you produce your 4,000 units, produce your D 4,000, C 8,000. So now that you have identified your order of units, how you are going to produce it, it doesn't mean that you are going to produce it following that order strictly. This production schedule is telling you how many units of each product you should do. So you will not say, oh, I will not do C until you finish D. On paper, you have identified that you can do all of D. On paper, you have identified that you can do all of C. On paper, you have identified that you can do all of A, part of A. If your customer needs A now, and they don't need C and D as urgent, you can go ahead and start doing your A, but make sure you don't exceed 2,000. So your customer wants maybe 50 of A, 50 of C, 50 of D. And maybe if he says 50 of B, you tell him, no, you can't get B. But I'll get the other ones for you now. So you do all this and you keep track of how many you've done so that you are using up your resources and you make sure that you're not going to exceed your 6,000 hours available. Now that's it. Let's see if we have another question here. Now look at this other question. A company makes 4 products using a single item of direct material. Once again, the hint is here. Same single item of direct material. They are giving you the hint that materials is your limiting factor. Budgeted data for the company is as follows. They give you all of these, like we usually saw in that product example LF3. So they've given you similar things here. So look at what they said. Due to restricted supply, only 78,000 of direct materials will be available during the year. So you look at it here, they say identify the quantities. Look at the question here, identify the quantities of production and sales of each product that will maximize annual profit. I've helped you to identify the limiting factor here because of 2 hints here. It gave us this hint, single direct material, same single direct material, same shows you that they are all competing for the same type of material. Let's say it's flour. They are all using the same type of flour. And now they said they are giving you only 78,000 naira. Now they said this is 78,000 naira of direct materials. Now look at it here. This question does not tell you the amount of material. It doesn't tell you the amount of material, like as in unit. It doesn't give you the number of units, but it gives you the value. It is you that will use this to get your value. So 78,000 naira worth of material. 78,000 naira worth of materials. So you see, this is a special type of limiting factor. I will not say special type. So you're not going to be, now they said direct material is going to be your limiting factor. So here, how do you change direct material? How do you change it from costs? How do you change it from costs to units? Now that's your assignment. So you see, like we did in labor, when we change our labor cost here to number of hours. Or if you look at it now, this is direct material cost is given to you in naira. That's fine. Your limiting factor is also given to you in naira, so there's no need to convert. There is no need to convert. So this is different from that of labor, where they give you labor costs and they give you your limiting factor in hours, then you now convert. So if you were told that the number of units for material is the limiting factor, then there will be a need for you to convert material costs to material units. But now they are giving you costs, and you also have cost here. So all you need to do is apply the 6 steps and you get the answer. Now, this is your assignment. Submit it to the WhatsApp group page. Summary of lecture. At the end of this topic, we were able to explain the issue of limiting factors. We say that limiting factors are that factor of production that different products are competing for. They are scarce in supply, and as a result of their scarcity and their importance, of course, it's the importance that determines their scarcity too, because if something is not scarce, it's not important. So anything that is scarce is important. So as a result of their importance and scarcity, it became a limiting factor. Now we have identified limiting factors. We said that there's going to be only one limiting factor. If you are not told, I'm giving you hints on how to identify this limiting factor. Then carry out a limiting factor analysis to formulate an optimal production plan. And I said these are 5 steps, and 6 steps rather. Step number 1, find the contribution per unit of each of the products. Step number 2, identify the limiting factor to the products. Step number 3, find the limiting factor per unit of each of the products. Step number 4, find the contribution per limiting factor of each of the products by saying contribution divided by limiting factor per unit. Step number 5, you carry out a ranking based on your contribution per limiting factor. And I said contribution per limiting factor is only gotten because we want to do ranking. Step number 6, prepare a production schedule based on your ranking. So your production schedule, we have your rank, products, the number of units you are supposed to produce, the scarce resources it's going to use up, and it's going to also show your contribution per unit and your total contribution. So when you get to the point where you have exhausted everything, of course, you cannot be moving from left to right. You now start moving from right to left. You do the opposite of what you normally do when you do from left to right. You normally say the number of units that is required multiplied by the scarce resource per unit will give you the number of scarce resources used up, that is going from left to right. When you've used up every of it, and the last one now, or the second to the last, or the next one you're handling now will make you exceed the scarce resources, you go the other way around. Find how many scarce resources is left, complete the total use up. Then you do the opposite. You now divide by the scarce resource per unit to get number of units that will be required to be made, that will be scaled down to. That is limiting factor. So you see, you have something limiting your providing these goods and services to your customers. That is limiting you. Also, you look at your scarce resources and you limit your scarce resources to producing what gives you higher contribution per scarce resources. And the one that gives you a lower contribution per scarce resource, you limit what you can produce. So you see the word limit, limit, limit keeps coming up recurrently. That's the end of the class for today. Let me see if I have a question from my participants. Let me see if I can see any question here. Okay, there is a chat here. Please, can you project the solution, sir? The solution has been in project. The solution has been projected all the while. Okay. The project has been all the while projected. Okay. With this, we come to the end of the class. Thank you so much for participating. See you again in the next class. Thank you.